Okay, guys, so let's start the contest. So, we have a question. Let's read the question. Telephone keypad are mapped with distinct collection of lowercase English letters which can be used to form words, pushing them. For example, the key 2 is mapped with A, B, C. We need to push the key one time to type A and two times to type C. Type B and three times type C. It's allowed to remap the keys to 9 distinct collection letter. The key can be remapped to any amount of letters, but each letter must be mapped to exactly one key. You need to find the minimum number of times the key will be pushed to type the string word. Okay, written the minimum number of pushes needed to type word after remapping the keys. Let's it's just like the old keypad phones we used to have. Some similar to that. We need to push three times to type C in this second button, and we can remap the buttons from 2 to 9. Okay, so we have to type these strings and we have to type it in least number of pushes. Okay, so let's turn to the question. What are we given with? We have given a word, and that's it. So first off, we are going to create a dictionary. That's going to be default, using default lambda, such that all the whatever value we don't have in the dictionary will have 0 as a count of it. And now we will store the count of all the alphabets in the word. So for in the words DC, let's make it DC because I prefer DC. A plus equals to 1. Now what do we have the count of all the letters. Now we'll make a pair of the letters. So we'll have array and we'll have pair of all the letters for DC. So this is how we're going to have. Now we have an array. So let's first off print the array to get a clear visual in our mind what we need to do next. So yeah, just run the code. Return 0 and run the code. Runtime error. Okay, words is not defined. Word, it's word. Okay, so what do we have here? Okay, now for all the test cases, right? So let's have another test case here, like this one, a bigger one. Run code, custom test case. Okay, now let's try to run it. Yeah, we have a list of all the numbers. So now what we need to do is we need to arrange it in ascending order, in descending order, sorry. Array dot sort dot, then ar dot reverse. So now what we have, we don't have any repeating element in this one, so let's add some repeating elements. Okay, that would be better. Run. Invalid test case. Why is that? Okay, all that fine. Word consists of lowercase English letter, all letters. Oh right, so we have all the distinct Okay, so we don't need this dictionary right now because we have all the distinct words, right? So it doesn't matter at all. We don't need all this. We just need a value n. N is equals to len of word. That's it. And then how many keys we can remap? Number of keys are 8. We can remap 8 keys. So yeah, we can remap 8 keys, right? So what do we need to do? We just need to count our answers. Answer equals to 0, and then n minus equals to 8. Okay. While n and c equals to 1. Okay. While n and d is equals to n divided by 8. Yeah, d is going to be that, and answer plus equals to d. Sorry for that. Answer plus equals to d into 8, and n is equals to n by 8, and c plus equals to 1, 8 into c, and that's it. Return answer. Let's try run this code. Okay, we don't have, just remove it. Unique. Okay, I know that already. All letters must be unique. So yeah, they're still judging it. It's taking too long. Time limit exceeded, they say. Okay, so we didn't. N is equals to n divided by remainder of 8, and that, I think that should do. Run it, god damn it. Why does it take so long? Time limit exceeded again. Okay. Oh, what is wrong here? Yeah, I know what's wrong here. Now I think we should get your answer. First off, we need to add only ones for the first 8, and then 2 into the next dividend of 8, just like we are doing here. the first n. Yeah, I think I know what's wrong here. N is not equals to this. N is equals to n minus 8. Yeah, that's what it should be equals to. And if d equals to 0, d equals to n divided by the remainder of 8, and this thing also be here, and break. Yeah, that should work just fine. Is there anything else we are missing? Let's run the code. We are getting 40. Okay, so that's a huge number. Should not be getting 40 here. Okay, so let me rethink what we want to do until we reach 8. Okay, why not doing it that way? No problem. I think no problem. C is going to be 1 and answer is going to be 4. Range, and if ct, okay, equals to 0, ct is equals to 8, that means c plus equals to 1 and ct equals to 0, and answer plus equals to c. Return. Should that work? We're getting 10 as an output, but should be getting 12 here. Okay, so there must be something wrong. Let's check for this one. Getting 5, that's right. What about this one? What about this one? Again we're getting 10. What's the value of n here? Okay, get it. Yeah, I think yeah, I think we should submit it now. Accepted. Yeah, so let's move on to the next question. I think we took too long for this question. It was just a simple question, but we took a lot of time here. How much time do we have? We still have plenty of time, I guess. Oh, not plenty of time. We have very less time here. So let's count the number of houses at a certain distance to a given positive integer n, x, and y. In a city, there exist house number 1, 2, and connected by n streets. There is a street connecting the house number I with the house number I plus 1. Okay, for all. Okay, so all the adjacent houses are connected. Okay, and additional street connects the houses numbered X with the house numbered Y for each case such that K is less than N, and need to find the number of pairs of house 1, house 2 such that minimum number of streets that need to be traveled to reach house 2 from house 1 in K is K. Acha. So we need to find the number of pairs of houses such that the minimum number of streets that need to be traveled to reach house 2 from house 1 is K. Return one index array result of length n, where result K represents the total number of pairs of houses such that minimum streets required to reach the houses from the other is K. Okay, so here we have three houses, n equals to 3 and x equals to 1 and y equals to, so we have only one street where we have one more extra street. Normally we have default case is that we have one street for each adjacent house, and we also have an extra street which is from x to y, in this case from 1 to 3. Okay, so that's what we have, and we have to return is that okay, so there is a return array where result can represent total number of pairs of houses such that minimum street required to reach the house from the other is K. So what is K? Okay, for each K, okay, result of K. Okay. So for the zero, so how many pairs are there in which we can 1 to t we can go from directly. Result 1 should be 1 2, how many houses there, so minimum here is 0. Okay, for every house we can go in 0 streets, right? So here that means in one street. Okay, directly number is K. Okay, now in this case, the second case, we have we have 5 houses just like this, and we have another street which is from 2 to 4. So here, to travel 0 or to travel one street and reach another house, we are able to do it for 1 2, for these two, one pair, second 1 2 3 4 5, for 5 pairs, right? 5 pairs, it should be 5, one pair, second pair, third pair, fourth pair, fifth pair. K equals to 1, the pairs are 1 2 2 1. Okay, so yeah, so it's should be double of 5. Okay, I get it. Yeah, right, I'm getting it. So basically it's a tree question. It looks like a tree, it's look like a map question to me, in which we have given edges all the edges, and we have to calculate the shortest path for each adjacent edges, and then we have to store it in a dictionary, and then we have to print out the okay, so I get it. So to reach, the length of array should be, what should be the length of array? The length of array should be n, right? 1 2 3 4 5, right? So 1 2 3 4 5, that can also be an answer, right? 3 4 1 2 3. For 3 we have 5 1 and 1 5. So those houses should be distant, that's given. Okay, but in this case can have same ones, right? So we can't travel the same path again. That's what given here. That is what's given here. We cannot travel to the same path. Be equal. Achha, it can be equal. It's given here that x and y can be equal, right? No problems. So here for 3 we can have 2 1 1 to 1. Don't seem like they are using it, because I don't see any 1 to 1. 1 to 1 here. So if it's like this, we don't have to consider this one, right? 1 2 3, we have 6 for for first one, and 4 for second, like 1 2 1 2 1 2 1 2 4. Okay, and 3 for 3 1 2 3 1 2 3. Okay, I get it. So yeah, let's jump to the I think we need to make a function here, our recursive function. Let's call it fun. And what are we going to pass here? We are going to pass here the current index, that is I, and the rest of the edges. So we know that we have adjacent edges, so but we need to know the limit, so we need to pass n here, and we also need to pass x and y here, right? So yeah, so from every current index, and we are going to store the dictionary. We are going to store dictionary here. Okay, yeah, we need to store the dictionary. This is our recursive function. And how many edges are we forming from first house? We need to calculate that, and we need to double it for each cases. No, we don't need to double it. We're going to calculate it for each house. Yeah, I think that's a good idea. That is definitely a good idea. So first we need to construct the edge list. So what are sorry for that. Called it lambda. So this is dictionary which is going to store our edge data. We need to create the edge data properly, and for that we are going to run a for loop, and we are going to store all the edges. So this will contain, for example, the key here is going to be index, and the value is going to be the list of all the other houses which are directly accessible from that index. Okay, so yeah, that's what we are going to do here. For I in range n, that means from 1 to n plus 1. Okay, so we are starting from 1, that's why I'm also starting from 1. Okay, now our DC, first off we need to store the if I is greater than 1, In that case, dc I dot append, dc I dot append I minus 1, okay, because, and if I is less than n plus 1, that means is less than n, that means we can have n, right? So dc dot append I plus 1 I, okay, and the last one is going to be if I is equals to x, then dc I dot append y, and if I equals to y, then dc of I dot append x, okay. So now we have created our edge dictionary here. Now we can perform the map function. So now we also need an answer dictionary. dc answer dc equals to lambda 0, okay. Or rather I should do this. Answer is going to be an array, right? An array of into n. This is, yeah, this thing is will be more effective. So yeah, now we don't have to pass all this. We just need I and dc and answer. These three things we need here, and we need the current count, ct, current count, that's current count, I call it ct, okay. So yeah, so ct, I mean answer ct plus equals to 1, and now we're going to travel to the next house, right? But we can't travel backwards. We just can't travel backwards. We only have to travel forwards, and we cannot jump to any previous house, right? Like we cannot go in loops like this one. We cannot go like that. That's given here. 1 3 3 1 1 4 4 1 2 5. Like they could have 2 4 directly, and 4 to 3 and 3 to 2. 2 4 is not here, right? 2 4 4 2. Okay, so they do have 4 2 here. Okay, 1 pairs 1 2. Okay, yeah. Like say 2 3 1 to 5. For k equals to 3, they have 1 to 5, 1 4 5 1 2 3, but they could have also gone with 1 comma 4, because we what I'm talking about. K equals to 3, they're only using this one. That doesn't make a sense to me. 1 5. Okay, I think I misunderstood the question. Okay, so we need to find the minimum number of streets. What are the constraints here? Okay, so the minimum number of streets needed to travel is going to be that particular number. So yeah, we just transform the question here. We'll just transform it. So yeah, what is the minimum we need to travel? Okay, so here we do have the dictionary of edges, right? So now this function will be returning all the pairs. So we will be making like a thousand, or sorry, 10,000 pairs, right? For every pair we are going to be calculating the minimum number of edges we require to reach that particular pair, and that particular pair is going to be added to the dictionary. Okay, our answer array. So it's good thing that we have already made. So what we need is, here is x, we need a destination, so we need destination, and we need our current dictionary, that means current path, past path, that means if we have already passed from that path, we need that. And what else do we need? We need ct. Do we need ct? I'm not sure. I think we need it or we don't. Okay, for now let's try our current index I, that's going to be I. And yeah, think that's it we need. If I in path, that means if we have already passed from I and we are again on I, will return. That means we are on a loop and we cannot have loops here. Will return infinity. And if else, if we are not in the loop, then our answer is going to be answer equals to, let's say it's going to be okay, answer is going to be infinity. And for a in dc, what's our dc I, for all the nodes directly connected from the ith node, we can perform we can travel, right? So x is going to be fun of the st, should be destination, right? So it should be st destination, then path plus I, and I is going to be a. We also need dc here. dc, yeah. So we'll call this function and we need to write an end case here. If I equals to t, st, if we have reached the destination, we'll return 0. Okay, we'll return 0. And for all the access So minimum of answer comma x, and we are going to choose the shortest path, right? And then what we need to do is answer plus equals to 1, because we have traveled one, so one step, that's why we are adding plus 1 here, and we're going to return answer. Okay, now we need to call this function for all the pairs, okay. Now for n, for j in range n 1 comma n, sorry, I to n, okay. J is going to range from I to n, and we will be calling our function x is equals to our function will have tc comma our destination, that's going to be j, and our path, that's going to be an empty list, and our current index, that's going to be I. So we're traveling from I to j, but the same answer is going to be for j to I as well. So if we get x, that means that's the minimum path, that's the minimum step we need to travel from to reach from I to j for this particular pair, the minimum value. And then if we get the value, then answer of the x is plus equals to 2. This is going to be the answer. Let's see what do we have here. We have a time limit exceeded, whatever. Let's see. Runtime error. So we are getting a float value. How is that possible? Okay, I get it. So if x not equals to infinity, that means if there is a path possible, yeah, finished. 620 for this one, you know. Okay, it should have been 600, but we're getting 313. Was it a 313? Yes, it is a 313. So yes, we are facing an error. Okay, hold on. Did I check? What if I write this part of code at the beginning? What if I do it like this? 620 again. Okay, so let's print out the results of all the pair. Print comma j comma x. So for 00, that means 00, 01, 02. Hold on, there is something wrong. Yeah, it should be I plus 1. Now I think, okay, now what's wrong here for 01, 02, 12? Okay. One to two, the result is one. 1 to 3, the result is 1. So all of them have result 1, and we, yeah, so for this one answer -1. Now let's try this other test case. 5 to 4. 5 to 4. Let's try to run this one. So what should be getting here? 10 8 and yeah, 10 8 200. Absolutely correct. Now let's try to submit this. Let's hope that we don't get a time limit exceeded error. Let's pray to God. If we do get it, then we are going to use dynamic programming here. So time limit exceeded, okay, no problem. So yeah, we can also use memo here. Memo if find path return memo. Okay, so what are the things that are changing here? The path is also a thing which we need to consider, and the memo is also a thing that we need to consider. Alright, so what if we write all these things in the memo, which we cannot do. Basically we cannot write all these things in the memo. Things that are changing here, the current index and destination. These two things are the things needs to be considered. Just try it. I think that let's keep it further now. I think let's skip this question because I don't know what to do next. Now we'll jump to the third question. Okay, so it's a similar type of question. Let's see how much time do we have. We don't have much time. Yeah, that's as minimum number of pushes to type word to question. Similar to that one, you are given a string word containing lowercase English letters. Keywords, a distinct collection of lowercase letters. You can use to word pushing, blah 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 blah, same thing. Now it's allowed to remap the keys from true to night, same thing. The keys can be remapped any amount of letters, but each letter must be okay. I think letters. So in this case, it's not given that we need all distinct. It's we don't have all distinct letters or all distinct alphabets. Okay. So yeah, right. So for this one, we need a dictionary. Voltect 0. Now we'll store the count of all the alphabets. Str dca equals to 1. all the alphabets need to, you know, we are storing the count of all the alphabets in our dictionary. Now we'll create a array of all the alphabets so that we can sort it in descending order. So our array is going to be an empty array first, then for ANDC array dot append DC DCA A count. We're storing the count, comma, the value for the alphabet. Okay, we're storing these things in our array dot so rt dot, it is in ascending order. Then now we have reversed array. Now let's print the array. Print the array and return. Okay. Oh, I'm sorry. Okay. So we have a dictionary here. Now we need this one here. For custom input. And this is our custom input. As you can see, you know what, we don't need this thing, we just need the amount. So yeah, there is a alphabet which occurs 6 times and one which occurs 2 times and so on. So we need to, you know, prioritize the one which is occurring the most of the times. Okay, that's, so we have our array required counts. So now for I for a an array, for a an array. Okay, so one thing we need to keep with us is going to be our current pending. Okay, pending equals to 0. So pending alphabets which we have not encrypted are 0. Okay, so first we need to encrypt the first 6 alphabets. Okay, 1 2 3 4 5 6, or we can just do it like this. Okay, we can do it like this for an array. Now we need a ct equals to 0, ct plus equals to 1 here if ct equals to 8, ct equals to 0, and c equals to plus equals to 1. 2 1. Okay, yeah. Now here, if our answer is going to be 0 and answer plus equals to ct, sorry, not ct, c into array, c into a. Yeah, the answer is going to be c into, answer is going to be answer plus c into a. Yeah, that's what we are going to do, and seat is going to be increased every time and return answer. Let's see if we get the right answer. C into A plus equals unsupported operation type. No problems. C into A. Think now it's fine. Or array contains. Okay, I'm getting it. Don't need this. Pen DCFA. Yeah. So we're getting a 24 as an output, which is absolutely correct. Let's try to submit it without printing the array. We haven't accepted. We have accepted. And let's try the last one. Holy shit, it's similar question. Okay, so what's the difference here? What's the difference that x and y can be equal? Okay, where the total number of pairs of houses that the minimum street required to reach house from the other is k. Okay, the minimum number of streets that need to be traveled to reach house 2 from house 1 is k. Okay, let's read it once again. In a city where there exist houses numbered from 1 to n connected by n streets. There is a street connecting the house number I with the house number I plus 1 for all. Okay, for all I less than n minus 1. An additional street connects the house numbered x with the house numbered y. For each k such that one case between 1 to n, you need to find the number of pairs houses such that the minimum number of streets that need to be traveled to house 2 to 1 is k. Okay, number of pairs such that with return index array result of length and where result k represents the total number of pairs such that the minimum street required to reach the house other house is k. Okay, I don't see any difference in the both of the questions. What is the difference here? I don't see any difference. That looks like same to me. Let's check the first one. I mean the second one. What's the difference? These two questions. What is the difference? First line is exactly same. Okay, in the city there exist houses numbered from 1 to n. Connected by n streets. Connected by n streets. Okay. There is street connecting the house numbered I with the house numbered I plus 1 for all. There is street connecting the house number I, the house number I plus 1 for all, an additional street. Why is this one elongated? Okay, everything looks exactly same. What is the difference between these two questions? I think these two questions are same. That's what I think. The outputs exactly same. 420. Both of them have exactly the same output, and if I try to run this, You know, you see, and if I'm trying to submit this one also, I will be getting a time limit exceeded error because these two questions are same. They are same questions. You see that? Both of these questions are same, but I don't know if I'm missing out on something. Okay, so what can we do to optimize this question? So right now what are we doing? We are using brute force method. We are using map to traverse and find the minimum distance between all two houses, all pairs of houses. Is that the optimal way of doing it? I don't know, I'm not sure, but that's what we are doing right now. So yeah, that's what we're doing right now. Now we know that they can have only one edge that's going to be like this, right? Yeah, that's it. That's right. So we can use greedy algorithm here because all the houses in line, yeah, we can definitely do greedy algorithm. First off, we need to calculate the distance between x and y. Okay. Yeah, I think we definitely going to use greedy algorithm here because as you know, to go from 1 to 2 we only have one way, right? And to go from 1 to 3 we only have one way, right? But in after this edge arrives we have another shortest path. So for every two hours we have only one shortest path, and that's and that's the the direct path jumping from each edges. Only for the houses which come in between this or after this are going to be separated, right? Absolutely right. Yeah, absolutely right. So 1 to 2, instead of writing this whole, we can just write two for loops. Just need two for loops here. Let's let keep it as it is. Let's comment this out. Okay, now we'll be writing our new algorithm. For answer is going to be our array, okay, of zeros or into n, okay, and for I in range n, for j in range n, sorry, I plus 1 comma n plus 1 plus 1 1 comma, okay. Now it's fine. Now the real twist arrives here. If these two edges are not having I mean if x is greater than equals to I and less than equals to j, if x is not between I and j and y is not, I mean I I mean if these two are not between I and j, then what is going to be our answer? our answer is going to be I minus j minus I, 5 minus 1, that's going to be 1 2 3 4, right? So answer j minus I plus equals to 1, right? But if this condition does not satisfy, that means any of these, that means, you know, okay, hold on. Yeah, if they both are not between them, then what we will do? Yeah, hold on. Minus, hold on. I think I've done something wrong here. So yeah, if these two are in between I and j, okay, so these two are in between I and j, so our answer is going to be, I mean, our minimum distance is going to be, md is going to be j minus I minus j minus I minus y minus x. This is what it's going to be. Sorry, minus y minus x. Okay, right? Yeah. So this is what our minimum distance is going to be. So answer md plus equals to 1. And if this is not the case, then our answer is going to be answer j minus I plus equals to 1. Return. Let's see if we get the right answer. Finished 120, which is a wrong answer. Absolutely wrong answer. 313, right? And we should be getting 6. Okay, so what is wrong here? Yeah, like say if I'm using 3. Okay. I forgot to do one thing. Plus 2, I have to do it. Plus 2 here and plus 2 here. Yeah, that's what we need to do. Two four zero. That's as well a wrong answer. For like this, say for this one, when we come to the conclusion, okay, so what we'll do here, we'll just print, I'll just print else md equals to j minus I. Okay, now let's print I comma j comma md equals to md. Let's run this. For 1 2, what is the md? 1. And for 1 to 3, it's the md. 0, no, that's not the md. So plus 1, we have to do plus 1 here. Now let's see. Yeah, so md plus equals to 2. Okay, so I think we should try the next test case, which is 5 to 4. because 5 to 4, because we are getting right answer for the first test case. Absolutely right. Let's try this one. 411. 411. Yo, 4 4. So we do have yeah. So in the case where I and j both are same, we should not be getting this thing to 0. So for 3, for 1 to 2, we're getting 2. Minimum distance is 2. Alright. Yeah, we can write an exception here. And I not equals to j. Okay, so now let's see. 4 4 2. For 1 to 2, what is the minimum distance? How can it be? I mean, yeah, how can it be? Plus 1. I not equals to j. Sorry. X not equals to y. Yeah, that should be there. Okay, 6 4 2. Alright, so yeah, I think we have all the border cases covered. 5 2 4, 5 2 4. I'm sorry, I wrote 3 here instead of 2. The answer 8 10 8. Oh yeah. And for the last one, 3 1 3. 3 1 3. Run it. Absolutely correct. Now let's try to submit this. Error? What's the error? List index out of range. Okay. 2 2 1 for 2 2 2 1. Well, in that case, okay. Alright, so what I'll do here, I won't do this thing, and I'll be declaring an array of size n plus 1. Yeah, that's what I'm going to be declaring, and let's see what we get. And I'll be returning answer 1. That's what I'm going to be returning. Let's see, what do we get? The output to 1. Two and 2 1 means a loop like that, so that will pass to this one. And if okay, so I'll write another and x minus x is greater than 1. All right. Alright, so yeah, let's check it out for the last one. 411. We have a wrong answer. Expected 311. Okay. Expected. What are you expecting from me? So we are missing a test case here for this one. 311 What's getting wrong? Let's print it out. What's wrong with this one now? So for 1 2 it's giving a right answer. For 1 to 3 it's giving a wrong answer. And why is that? No, it's not giving a wrong answer, it's giving a right answer again. For 2 to 3 it's giving a right answer. Then what's the issue here? MD should have 4, and 1 to 3 it's giving a wrong answer. Yeah, so for 1 to 3 x and y are in this range, and if I just remove this line, these few things expected. Okay, list index out of range. So okay, and why is that? 1 to 3 we are getting an output minus x, j minus I, that's 2, minus y minus x, that's 2 again, plus 1. So how is that an issue? How is that becoming an issue for you, huh? Because MD becomes, for 1 3, how does MD becomes 5? I don't get it. MD is becoming 5 for 1 to 3. Okay, I get it now. That should be 1 3, yeah. Our code should. Oh, now what is wrong with you, Captain? 1 5. So we have 1 and 5 connected. So our output should be this, but our output is being returned. The output being returned here is this. I do see an error here. We are adding something to, let's say, if we have 5, yeah, so our we have this. Okay, so yeah, I have a bigger line. So our question is something like this. They are connected, not this one, but we have this one, right? So for each of them it's conventional, but for only this one we have one. So one should have 1 2 3 4 5. I means 10. One should have 10, right? So we have 10 in one place, but for the second one, like from here to here. Okay, so that's where the twist comes. Yeah, I get it. I get it. I definitely get it. Okay. Okay. Okay, I get it. I get it now. I get what's wrong here. So we just have to reconstruct everything, I guess. We have to reconstruct everything. Well, is this really necessary? We need to have a dictionary for each and every one of them, or an array for each and every one of them. So we need a two-dimensional array which we can in which we can store the minimum values. So yeah, that's a more appropriate way of doing this question. It was good that we came this far. How much time do we have? We have 6 minutes. Let's try doing it in 6 minutes. So yeah, let's try doing it in 6 minutes. Now let's comment this out as well, because that's of no use to us. Now we need an array that's going to be two-dimensional. And what do we need in our array? We need ij pairs, and the I comma j index is going to store the minimum value that is required to reach from I to j. And first off, we need infinity to be stored in all the arrays. Out of them, then we are going to decide the minimum. Yeah, I think that's a proper way of doing it, doing the business. Yeah, okay. Let's construct it first. We need a array for so we need to construct an array, right? So array dot append and yeah, 0. So yeah, we're going to have something like this. 0 1 2 3 4 0 1 2 3. Let's consider this one, this part only. We are going to need more here. 4. Let's consider this part. Okay, so to reach from 0 to 0 we need 0, right? Actually we don't need this one. Okay, so for to reach from 0 to 1 we need 1, to reach from 0 to 2 we need 2, to reach from 0 to 3 we need 3, but to reach from 1 to 5 we need 1 to 5 we need 1. Okay, now to reach from 1 to 4, how much do we need? Minimum of this plus 1, or minimum of this plus 1. Okay, these two minimum is going to be here, right? So we just need to call another function that's going to modify this one for us. So till here it's all good. Just need to call another function here. Function I comma j. To reach from 1 to, and similarly for 5 to, we just modify something in our array of x comma y minus 1 plus 1 is equals to 1, and same thing, array of y minus 1 comma x minus 1 is equals to 1. Both are going to be 1. Okay, now we'll perform an operation that will alter these two indexes. That will work on from these two indexes and will spread till it can spread. Okay, from 1 to this particular index, how much is it going to be? Let's see how much time is left here. Okay, sorry, the context has already been ended, but yeah, we were able to solve 2 of these questions, and we were unable to solve the 2 questions though, which are exactly same questions. Okay, no problem. Let's see what is our score. So yeah, the score is 8, and our ranking is very very poor, but still we tried. Yeah, we tried, definitely tried. And okay, keep following this channel. This time we were not able to solve all the questions, but who knows, next time. Thank you for watching.